Hi guys, welcome to the solution of the challenge question in post. The question is of the electricity chapter of CBSE Class 10. However, the objective to post this question is to clarify the concepts of electric power, power dissipation, voltage drop, and understanding in depth the concept of series and parallel combination of resistors. Recall, power is the rate at which work is done or the rate at which energy is transferred or converted. In electrical systems, power is the rate at which electrical energy is transferred or used. Mathematically, power is ratio of electrical energy consumed divided by time taken to consume. Its unit is watt. The commercial unit is kilowatt hour or kilowatt hours. Recall and remember the basic formula that power is a product of voltage and current. From Ohm's law, the current is equal to voltage divided by resistance. Hence, P equals voltage squared divided by resistance. Here is the question. Two bulbs rated 40 watts, 110 volt, and 60 watts, 110 volt, are connected in parallel, and this combination is connected to a 220 volt supply. Which of these bulb fuses? Here a typical circuit for your reference. Recall and recap the power formulae discussed just now. For your reference, here are the formulae. Using these formulae, let's calculate the rated current and resistance for each of the bulbs. For bulb 1, the rated current is 0.36 or 4 by 11 amperes. The resistance of the bulb 1 is 605 by 2 or 302.5 ohms. Similarly, let's calculate the rated current and resistance of bulb 2. For bulb 2, the rated current is 0.54 or 6 by 11 amperes. The resistance of the bulb 1 is 605 by 3 or 201.67 ohms. The calculated rated current and resistance of each bulb is summarized below. When bulbs are connected in parallel and connected to 220 V supply, current in each bulb can be calculated with Ohm's law, I equals V by R. We have already calculated resistance of each bulb. Let's now calculate the actual current flowing through these bulbs. The current through bulb 1 is 0.727 ampere, and through bulb 2 is 1.04 ampere. Observe clearly that the current flowing through each bulb exceeds the rated current. So think what would happen to the bulb. Bulbs, when connected in parallel across 220 volt, the current in each bulb exceeds the rated current. Hence, both the bulb will be fused. We can support our conclusion further by calculating power dissipated by each bulb. The power dissipated P by each bulb is given by power P equals current I square multiplied by resistance R. Let's calculate power dissipated by each bulb. The power dissipated by bulb 1 is 140 watts or 140 joules per second, and that of bulb 2 is 240 watts of joules per second. Here is the summarized calculated and rated data. For bulb 1, the actual power exceeds the rated power. Hence, bulb will be fused. Also, for bulb 2, the actual power exceeds the rated power. Hence, bulb 2 will also be fused. Now, let's us think that what would have happened if these two bulbs are connected in series across the same 220-volt supply. Here is a circuit for your reference to visualize the series connection. Recall in series connection, the equivalent resistance is the sum of resistance of each resistors in series combination. Also recall, same current flows through each resistors in series combination. Here is the summary of resistance calculated for each bulb. Resistance of 40 watt 110 volt bulb. R1 equals 302.5 ohms. Resistance of 60 watt 110 volt bulb. R2 equals 201.67 ohms. Total resistance in series. In a series connection, the total resistance is R total equals R1 plus R2 equals 302.5 plus 201.67. Equals 504.17 ohms. Now the total current is calculated as follows. From Ohm's law, I total equals V supply by R total equals 504.17 by 220 is almost equal to 0.436 ampere. The same current flows through both bulbs, since they are in series. Recall voltage across each resistor or bulb is calculated as a product of current flowing through it and resistance of each bulb or resistor. Voltage drop across bulb 1. V1 equals 0.436 multiplied by 302.5 is almost equal to 131.9 volt. Voltage drop across bulb 2. V2 equals 0.436 multiplied by 201.67 is almost equal to 87.9 volt. Let's calculate power dissipation in series combination. Power dissipated by each bulb. The power dissipated P by each bulb is given by P equals I squared multiplied by R. Power dissipated by bulb 1. P1 equals 0.436 square multiplied by 302.5 is almost equal to 57.5 watts. Power dissipated by bulb 2. P2 equals 0.436 square multiplied by 201.67 is almost equal to 38.3 watts. Analyze the results. 1. Bulb 1, 40 watt 110 volt. Designed for 40 watt but dissipates 57.5 watt, which exceeds its rated power. Bulb 1 will likely fuse. 2. Bulb 2, 60 watt 110 volt. Designed for 60 watt but dissipates 38.3 watt, which is within its rated power. Conclusion. When connected in series, bulb 1, 40 watt 110 volt, will fuse due to excess power dissipation. Bulb 2, 60 watt 110 volt, will likely remain intact, but will glow dimly because it receives less voltage and power than its rating. This configuration causes uneven voltage distribution, leading to the failure of one bulb. I hope, guys, you might have enjoyed watching the solution of the challenge question. The more that this example should have cleared many of your doubts. Thank you for watching the video. Don't forget to subscribe to my channel. I hope the solution of this challenge might have cleared many doubts of electricity chapter. Please like the video, share it with friends, and subscribe for upcoming challenge questions. Thank you again, guys, for watching the video.